Hello everyone, my partner and I are doing this project called as Auto Irrigation System. We realized that water is an essential key factor in agriculture. However, the traditional method of plant watering is not accurate, as we know that every crop needs different amount of water, and that amount of water can be varied during different seasons and humidity or temperature at a certain place. And we do know that sometimes the farmer may give not enough water or sometimes a bit too much water to the plant. So we came up with this project as we want to improve the plant watering system, and we thought that if we can use water efficiently, it will be beneficial for the farmer because the farmer can reduce unwanted water usage and also reduce extra labor costs.
So this is our flowchart for irrigation system. The program starts by sensing the moisture level of the soil. Then, if the soil level is less than or equal to 25%, the LCD shows extremely dry soil. DC motor and LED will turn on at the same time. However, when LCD indicates dry soil if it sends more than 25 but less than 50% humidity in the ground, DC motor and LED will turn on right after it. But if the sensor detects humidity higher than 75%, wet soil will be displayed on LCD screen. Consequently, both the DC motor and LED will not turn on. The program does not stop until the power is turned off.
So this is the block diagram of the system. So as we can see, the soil moisture sensor is connected at pin RA1 at port A of 616F877A microcontroller. It is an input port. It also connected to a 5-volt power supply, and we also connected the 5-volt power supply to the MPLAB pin for recycling. At output port, we have LCD, LED and transistor. So LCD we connected at port D, and then we have LED at pin RC4 and transistor at pin RC0. So we connect a motor, a DC motor, to the transistor. So this is our schematic diagram. We connect our soil moisture sensor to port A of the microcontroller, and then we connect the transistor and motor at port C of the microcontroller. This is the LED at pin RC4 and LCD at port D of the microcontroller.
This is the PCB layout for our irrigation system. This PCB design can help to reduce errors before the actual chip is built and refrain short circuit from happening. So RV1 and RV2 is the potentiometer. This is LCD. This U3 is indicates peak 16 microcontroller. This is transistor, LED, and lastly resistor.
This is the 3D visualizer. So 3D visualizer will show just the same as the PCB layout but in a 3D form of the components.
Since this is our coding for the irrigation system, firstly, the LCD ports must be initialized first. Register select pin at LCD is connected with RD0 of the microcontroller. Next, the enable pin is connected to RD1 pin, while the D4 pin is connected to RD2 pin at the microcontroller. The D5 pin is connected to RD3, while D6 pin is connected with RD4 pin, and lastly, D7 pin at LCD is connected with RD5 pin. This program also needs ADC initialization. At this function, it is to turn on the ADC module and to select the desired clock. Next, to read ADC value at the potentiometer, the ADC read must be written on this program. Next, for the PWM program, there are two functions to generate PWM signal for the microcontroller. The first function is PWM initialize function. This function will initialize registers that are required in setting up PWM. So this is the formula to make the PWM work in 5 kHz. 3C2 is reset to 0 to make port C as output. The next PWM function is PWM duty. This function works to set the duty cycle of PWM in the desired register. So this is the formula for the duty cycle. We also need to add LCD function on this coding since we use LCD in our irrigation system. So LCD command is actually to make a command for the program. Meanwhile, for LCD clear function, it has two commands under it, which are LCD command 0 and LCD command 1. The meaning behind LCD command 0 is to clear the LCD, while LCD command 1 is to move the cursor to the first position in the LCD display.
As for LCD set cursor, it is to set the position of character on the LCD screen.
For LCD start, it is important in our program in order to start working with the LCD. So under this LCD start function, it has command for the LCD. For LCD print character, it is to send the character on the LCD, while the calling function of LCD print string is to display the characters on the LCD. Lastly, for the main function, which is int main, under this function, it has all the calling function that needs to be called in order to display the code. In the microcontroller, 3A works as input port, and 3C and 3D is initialized as output port. Under main function, it is also required to call PWM and ADC function that are initialized before the int main.
Under while loop, we use if-else statement, and it is also has the formula for moisture sensing.
If the moisture is more than 41, the LCD will display wet to indicate the humidity of the soil is enough, making the duty cycle to work only at 128.
RC0 and RC1 pins is set to make the potentiometer and LED on.
If the moisture level is less than 11.25, the LCD will display extremely dry to indicate the soil does not have enough water. Hence, the duty cycle is at 512. Lastly, if the moisture is in between 22.5 and 40, the LCD will be print dry on the screen, making the duty cycle is only at 256. I think that's all for the coding.
As a conclusion, I would say that we are able to plan our project very well because we made a flowchart that is the guide for us to build the coding of this system, and then we have a block diagram which we refer to when we want to connect all those components in a circuit. And then in terms of the coding for this system, we had learned on how to use the ADC modules, PWM modules, and LCD modules in our coding. We need to initialize all those modules first before we actually use it in the main part of our coding. We learn on how to print a character or string in our LCD based on the results or data we get from the microcontroller, and then we are able to create a PCB layout of this circuit and also the 3D visualizer. However, we are unable to finish or complete this project as we cannot mix the LCD to display another conditions. We managed to get until the extremely dry condition. We cannot make the LCD to show or to display wet and dry condition. So we are unable to fix that problem in our coding.